Entomic's Biosystems is built around this core concept of insect bioconversion, whereby insects can eat food wastes and other different types of waste biomass and bioconvert that into fats and proteins, which are great sources of nutrition for the animal feed industry. Here at Entomic's, very specifically, we focus on enhancing and tailoring these insect-derived feeds to create functional benefits for certain targeted applications. So what we have here are black soldier fly larvae, and they're chewing through food waste and metabolizing it very efficiently into proteins and fats as they grow. They grow about 5,000 times their own body weight over the course of 2 weeks, so a very efficient conversion engine. And the proteins and fats from these insects are a really interesting, sustainable, high-quality ingredient for the farmed salmon industry, given that farmed salmon in Scotland, for example, are currently fed on fish meal, which comes from wild-caught anchovies from as far away as Chile in Peru, which are then shipped across the world to Scotland. So insects represent a nice, sustainable solution. Each week, we pick up several tons of food waste from local supermarkets and food processing operators. We feed the insects different recipes under controlled conditions and test for differences in growth rates and end nutritional profiles. So what we're doing here in this room is essentially gathering data on a pretty complex biological system so that we can build out a smart, autonomous system for insect production in the future. So Entomic's Biosystems is an insect biotechnology company, and it was formed by a couple of University of Cambridge students a few years ago, and it really was one of those stories where we came together basically at the pub over a pint talking about weird ideas. And the team actually has members from the Department of Biochemistry, from engineering, from the business school, so it really was a very diverse skill set, but it's one of those weird businesses which kind of needs that input from different disciplines. So we've developed a bioprocessing step which allows us to optimise and tweak these types of insect-based profiles to target specific nutritional applications for specific animals.
What Entomic's is largely focusing on at the moment is the advanced processing of maggots of the insect biomass, if you could put it that way. And we're doing that by using a process that we've sort of fancily codenamed metamorphosis. In more lay terms, we're essentially fermenting the insect biomass and the various fractions of an insect, this being protein, fats, and chitin, which is the shell of the insect. And there's several benefits of doing this process, from affecting the gut microbiome and trying to preserve a healthier community there, to training immune systems to make livestock more resistant to disease challenges, and at the same time reduce the need for veterinary medicines, antibiotics, and vaccines.
So right now we're doing a lot of work with partners like the University of Stirling, who are world-leading salmon aquaculture experts, to validate and test some of these products in the field. And it's a really interesting area in general, and there's so much potential in terms of other applications around insect biotechnology and using insects as a vehicle for creating high-value products and services. And as an example, we're also working on machine learning algorithms to try and track behaviours of insects during the production process and trying to understand really complex data sets in terms of how they behave and how we can actually optimise different types of engineering systems to address that. The world's looking for more sustainable sources of feed, and I think increasingly there's a recognition that it's not just about basic nutrition, but it's about overall health. So I think we're really trying to take a sustainable, sort of promising ingredient of the future, with insect-derived feeds, and trying to add a bit of biotechnology or science focus to it to really enhance what the effect is in the end application and reduce reliance on traditional antibiotics and veterinary medicines.